Hello and welcome to another episode of Better Together at Science with Shinrai Sensei. And today we're going to go over the periodic table. We're not going to go over like every single element or anything like that. We're just going to kind of give you some basics. So you can see that this yellow group or family, this is a family known as the alkali metals. Then this slightly brownish tan color is the alkaline earth metals, right? Then this light purple color, which is these elements here, right? They're called lanthanides, right? Then right below them is the actinides. You have the transition metals, which is all of these green colored ones. This lime, kind of I wouldn't say lime green, but greenish colored, right? Then this slightly darker purple, rather than like a somewhere between pink and purple, this darker purple here has unknown properties. So they're a grouping of their own. They are a assembly of their own with the trait unknown properties. Then post-transition metals is this orange, right? Then metalloids is this light pink. Other non-metals is this light blue, right? The halogens, your fluorine, your chlorine, your bromine, iodine, such like that. Those are your halogens. And then your noble gases, right? So the new and pending discoveries is also the same color as the ones with the unknown properties. So there's new discoveries being made constantly about those. But there's your periodic table, and I'll zoom that in or hold that close so you guys can see what each color means. Take a screenshot of this and take a screenshot of this, and then you have the periodic table and a little bit of a breakdown on what every single assembly of elements is and what their properties are, right? And what they are called in that little assembly. And another thing about the alkali metals and the alkaline earth metals is they are extremely reactive with water, right? But, so going horizontally is known as a period in the periodic table. And then vertically is a group or a family. And more than likely, when those two terms were coined for the periodic table was created in 1869. So the periodic table back then was probably so simple that the vertical and horizontal makeup of the periodic table was pretty much grouping them together by, types of elements and what we knew about them at the time, which is usually their chemical reactivity and stuff like that, right? So period is this way, group is this way, right? Pretty simple. And then another thing to note is the atomic number, which is how we organize them now, is the number of protons in every single atom, right? The number of protons in the atom is what determines the atomic number. And then the atomic weight is typically the weight of the protons and the neutrons, because the electrons themselves are so small that the amount of weight that they donate to the actual mass of the atom is so minute. It's measured in very, very small decimal points, right? So the atomic mass is usually just the addition of how many protons and how many neutrons is the atomic mass, usually, of the average atom, by the way, the average atom. Atoms that are heavier or atoms that are lighter on neutrons are what's called an isotope, right? So I'll go ahead and write that up. I'll write up a few of these definitions real quick so that we have them. periodic table, and then I'll write the definitions in red here. So, period is going horizontal, group or family is going vertical, right? Then atomic number, pardon me, my U is leaving a little bit to be desired here. Got to bust out the fuzzy eraser here. All right. Number is the number of protons atomic weight, average weight of atom. Right? So the average weight of the atom is the atomic weight, and usually consists of the weight of the neutron and the proton, right? And I will say Mendeleev created 1869, right? Let me close the parentheses so that doesn't look awkward. All right, so there's just some basic definitions, right? Mendeleev created the periodic table in 1869. A period is going horizontal, group or family is going vertical, atomic number is the number of protons, atomic weight is the average weight of the atom. In that particular atom's case, there could be heavier isotopes. Oh, yep, that's what I was going to write the definition of. Sorry, guys, I kind of forgot. So, isotope is atom with different than average number of neutrons. Right? So an isotope, the weight difference will come in, and you'll have like heavier atoms and lighter atoms based on how many neutrons they have, right? So there's just some basic definitions for the periodic table and some elements and stuff like that. And once again, if you guys do have any questions, please leave them in the comments section below. And also, if you guys want at any point in time, like I was saying when I was holding up the book earlier for you guys, please take a screenshot of the page, take a screenshot of any information that you think is valuable that I'm writing on the board, and keep it as a study material. I don't really want to make you guys have to draw the entire periodic table for yourselves, or have to highlight it all for yourselves if you don't have to. If it helps you to memorize it, please do. But if you don't, if it doesn't help you memorize it and you don't really have a value in doing it, I don't see why you should. So please just go ahead and take screenshots of anything valuable, anything useful that I have taught you. And I look forward to seeing you guys in the next episode. Thanks for coming out.